Hi, welcome to lesson 5.3, proving triangle congruence by using the side angle side method. So the first thing we're going to need is, we're going to start with a construction. So please make sure you have a half sheet of paper glued on page 133. And the construction that we are doing is copying a triangle using the side angle side method. Okay. All right, so if you turn to the next page, please cross out the table. Okay, we are not going to use the table. And please prepare the bottom of page 134 for your example number 1. Okay, so don't worry about what it says here for number 2. We're just going to use the blank space. If you want to use a quarter of a piece of paper and just glue it on top of all of this, you can do that too, but that's for problem number 1. On the next page, we are going to do problem number 2 on page 135 and problem number 3 right here. This is the theorem that we are going to investigate. It's called the side angle side congruence theorem. So let's go back to the exploration, and we're going to start with a construction. Now the constructions, they're my means of introducing the main concept. So here's what we're going to do. We are going to copy a triangle using the side angle side method. So what I want you to do first is I want you to draw yourself a triangle on the top half of this page. Now draw it so that it's it's a decent size. Okay, so draw your triangle. Okay, so there's your triangle. I'm going to call this triangle A, B, and C. Now, I am going to copy this side right here. I'm going to copy this angle right here, and I'm going to copy this side onto the bottom portion, and I'm going to show you guys how to do that. Now for this, you probably want to start using a pencil just in case you make mistakes. Okay, so in order to do this, what you need to do is, first thing we're going to do is we're going to copy segment AB. Okay, so in order to do that, you need to draw yourself a segment that is bigger than AB. And I'm going to make sure you guys give yourself enough space. That way, you can fit your triangle in there. So what I want you to do is I just want you to draw a line. Make that line bigger than what AB is, like this. And pick a point somewhere on this. I'm going to pick this one right here, and that's going to be my copy of A prime. So what you're going to do is you're going to use your compass, and you're going to measure the distance from A to B. So I'm going to measure it from A to B, and it's about this much. Probably a little more. Okay, so that's the distance from A to B. I'm going to pick it up, put it on A prime, and draw myself a little arc right there. And that point of intersection, I'm going to call that B prime. Okay, now AB is the same distance as A prime and B prime. Okay, so far I have made this distance and this distance the same. The next thing I want to do is I want to copy this angle right there, angle A. So in order to do that, you need to create an arc. Okay, just make it less than AC. Okay, so from here I'm going to create an arc. Now sometimes it's easier if you turn the paper around like this so that the angle is facing away from you. So from here I'm going to draw a line, not a line, but an arc going like that. Okay, now without changing it, go to A prime and draw yourself another arc. Okay, All right, so now in order to copy the angle, you have to measure from here to here. So like this, from here to here, you measure it like this. Hopefully you guys can see that. I can probably stick my pencil out a little bit more. Okay, from here to here. And then copy it from here to here. Right, from there. Now, when you get that, you're going to grab your protractor from A prime to that point of intersection. You're going to draw a line and make sure it looks bigger than AC. Okay, so what I did right now is I just copied this angle right here. Okay, so that's that angle right there. Now the last step here, well, not the last step, but is to measure from A to C. Okay, from A to C, right there. Or you can see it, my hand's in the way. From A to C. And put it on A prime. Draw yourself a little arc. And this point right here is going to be my C prime. All right. So what I just did is I copied AC. Okay, so this is congruent to this. Now what I'm going to do is I am going to finalize my triangle by joining that point, my B prime, to my C prime. Now my question is, are these two triangles congruent? Well, here's the thing. I only copied the side, the angle, and the side. So if these two happen to have the remaining parts congruent, then they're going to be congruent. So let's verify that. If I look at BC, and if I were to measure BC, BC is about 8.3 centimeters. Now this one is also about 8.3 centimeters. Okay, it's not going to be exactly the same, guys, so don't worry about it if it's not the same. Oh no, I was wrong. About 8.1, sorry. And this one is also about 8.1. So the sides are the same. Now if I look at this angle right here, this angle happens to be about 36 degrees or so. This one right here also happens to be about 36 degrees or so. Okay, and if I do the same thing for this one and this one, they're going to be the same. So technically, these two triangles are going to be congruent. Now, the only thing that we made sure that was congruent were a pair of sides and an angle. Okay, so here's what we had. We had AB congruent to A prime, B prime, and we also had an included angle. Here's a big word, included. Okay, this angle here is considered to be an included angle. If you guys hear crying in the background, my son's doing a tantrum. Wife is handling it. Okay, so this is an included angle because it's like sandwiched in between two sides. Okay, so the included angle here happens to be A and A prime. Okay, and then the other side would be AC and A prime, C prime. So if you have two triangles that have two pairs of sides that are congruent and a congruent included side, then the two triangles are going to be congruent. So therefore here, triangle ABC is going to be congruent to triangle A prime, B prime, and C prime. And we only needed these pieces of information. We needed two congruent sides and one congruent included angle. Okay? This is called the side angle side congruence theorem. Okay, so using it is so much easier than proving it. So the side angle side theorem, congruence theorem, is on page 135. It states if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. We no longer need all the pairs of sides and all the pairs of angles to be congruent in order to show that two triangles are congruent. All we need is what we just said. Two pairs of sides and an included angle being congruent, and voila, your triangles are congruent. Okay, so let's go ahead and look at some examples for 5.3. Let's look at problem number 1 first. Okay, so here is problem number 1. Let's look at that. Okay, now sometimes it's going to be very obvious when they're going to be congruent and when they're not going to be congruent. Okay, you just need some additional information that sometimes it's not provided. You have to like go dig for it. Now, looking at these two, this diagram, here's what they're asking me to do. They want me to prove that triangle ABC and CDA, that they're congruent. And the only thing that I have right now is one pair of sides. Now, I want to use my side angle side congruence theorem. And according to what I have right now, I only have one pair of sides, which is BC and DA. That's it. That's all I have. That means I need a third pair and I need an included angle. So where is that coming from? Well, let's see. Here's the thing. You notice that AC, okay, is a common shared side. Okay, so AC is going to be congruent to itself, CA. That's called the reflexive property. That means that this side right here is going to be congruent to itself. So if I look at it like this, I have a triangle where I have a marking of 1 and 2. And on this one, I have another triangle with 1 and 2. So now I have this already. I just need my included angle. Now, here's a very important piece of information. These lines are parallel. So this is a transversal. Okay. Now, because this is a transversal, that implies that this angle and this angle right here, they are congruent by alternate interior angles. So voila, I already have my third piece of information. The first one was given to me. The other two I deducted based on my prior knowledge about the reflexive property of congruence and alternate interior angles. So if you're having a difficult time remembering alternate interior angles, please go back and check your notes in chapter 3, because that's when we covered parallel lines, cut by transversals. So now I have a plan. Okay, I have a plan. I haven't even started the proof yet. We're going to do that right now. Okay, so go ahead and set up your two columns. The first thing that I have here is my given. They tell me here that BC is congruent to DA and that BC is parallel to AD. That's given. Okay, so let me focus on the sides first. Okay, I know that AC is congruent to itself. So AC is congruent to CA. Okay, so that is the reflexive property of congruence. Okay, so look, I already have my two sides. Now all I need is my interior angle. So my interior angle is going to be this one and this one. Okay, so I'm going to call it angle BCA is congruent to, now I'm going to use this to get the next part, BCA DAC. and that is my alternate interior angle theorem. So look, I already have my side, which is this one right here. That's my side. My other side, and then my interior angle. Now, they don't have to be in order, okay? But I do have side, angle, side. Look, side, angle, side, side, angle, side. So therefore, triangle ABC is congruent to triangle CDA by the side angle side congruence theorem. Remember what side angle side needs. It needs two pairs of sides, which you have right here, this one and this one, and an included angle, which happens to be this one. Okay, so this is a full formal proof. This one was actually not that long. It was only four lines, but the most we've done in this class is probably like 12 lines. Okay, we're gonna try to avoid those, but they can come up. All right, so side angle side. We just proved that these two triangles are congruent by side angle side. All right, let's look at the next one. Now this one says in the diagram QS and RP pass through the center M of the circle. What can you conclude? Now this is not a proof. It doesn't say proof. But I want you guys to pay very close attention to this diagram because it tells you here that M is the center of the circle. That means the distance from M to P, M to Q, M to S, and M to R, they're all the same because it's a radius. So this one here is congruent to this one here. That one there is congruent to that one there. Okay. Now I want you to take a look at this angle here and this angle here. Well, aren't these two angles here vertical angles? Yes, they sure are. So this angle and this angle here are congruent. Okay, so look at what you have. You have two pairs of sides that are congruent. This one and this one, this one and this one, and an included angle. Therefore, the triangles are going to be congruent by side angle side. Okay, so here's what you have. You have MS, okay, MS congruent to MQ. You also have MR, okay, congruent to MP. Okay, there's your two sides. This is the top result. Oops, sorry, my phone just went off. I don't know what happened to it. Okay, so these are your, it scared the heck out of me. Here's your two sides that are congruent and your included angle, the one that's sandwiched in the middle. Okay, it's angle SMR, okay, SMR QMP. Okay, so here it is, side, angle, side. Oh, can't see that. All right, so therefore, I can now state that triangle MRS is congruent to triangle MPQ. Now, this is not a proof, but I can easily turn this into one if I wanted to. And that's example number 2. Let's look at number 3. Okay. Zoom in a little bit. I know the diagram's a little hard to see, but it says you're making a canvas sign to hang on the triangular portion of the barn wall shown in the picture. You think you can use two identical triangular sheets of canvas. You know that RP is perpendicular to QS and PQ is congruent to PS. Use the side angle side congruence theorem to show that the triangles are congruent. So I'm going to redraw this just so you can see what the heck is going on here. So you have a big triangular piece of roofing here where you have Q, S, R, and P. Now, according to this, RP is perpendicular to QS. That means that is a right angle. Okay? It also tells you that PQ is congruent to PS. So what they're asking me, they're trying to ask me to prove in a way that this triangle and this triangle are congruent by side angle side. So look, you have your pair of sides, okay? You have your angle, your included angle. So all you need is another side. And that side is going to come from RP, because RP is congruent to itself. Any segment is congruent to itself. Okay? So RP congruent to RP. Now, how come I didn't switch the order of the letter? Look at how the diagram is drawn. Okay? Go by this also. RP, RP. So here is your other side. So therefore, the triangles are now congruent by side angle side. If you hear noise in the background, my kids are doing tantrums again. They're almost 6 and 3. All right, so these triangles are congruent by side angle side. So these were given, okay, and this one was deducted. Now, why didn't I switch them? Because look, RP, RP. And that is example number 3. And the last example, actually. So please make sure you guys are working on the extra practice, and I will see you all later.